Lesson 12.4, Counting Methods. A tree diagram is a branching diagram that shows all the possible choices or outcomes of a process carried out in several stages. In example 1, you are choosing a sub. You can choose white or wheat for the bread, ham, turkey, steak or meatball, or bologna for the meat. How many subs are possible? We can use a tree diagram to count the number of possible subs. Our two choices were white and wheat. From the white, we had ham, turkey, steak, meatball, and bologna choice. For the wheat, we had the same choices. Now all you have to do is count the last part of the tree diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possible sub-choices. We can also use the counting principle instead of a tree diagram. The counting principle says if one event can occur in m ways, then a second event can occur in n ways. You can multiply these two numbers together. And you can extend this counting principle to 3 or more events. Just as an example for an example 1, you had two choices for the bread, times was there 1, 2, 3, 4, 5 choices. For the type of meat, 2 times 5, 10 choices. In example 1, a campground provides a variety of activities for its campers. In the morning, you can choose fishing, nature walk, canoe trip, or arts and crafts. In the afternoon, you can choose swimming, hiking, wagon ride, or bike trip. To count the number of different pairs of activities you can participate in, use the counting principle. So the morning was 1, 2, 3, 4 choices. The afternoon also had 4 choices. That is a total of 16 choices or different pairs of activities. Again, you can go fishing or swimming, nature walk and hiking. We can also use the counting principle to figure out how many different license plates are possible. And we do actually use this when we are determining what type of license plate you might get on your new car. A license plate starts with 3 letters and then 3 digits. So, how many letters are in an alphabet? 26. Because you can repeat the letters, like I could have B, B, B in my license plate, there's going to be the second choice is 26. So again, this is your first place in your license plate. This is the second place in your license plate, and then the third is a letter. So again, it starts with 3 letters, then it has 3 digits. Now the digits are 0 through 9. 10 is not in there because that's a double digit. So again, I can repeat the digits, so 10 times 10. Multiply this together, you get 17,576,000 choices for license plates. For example 1, count the choices. It does tell you to use a tree diagram, so please use a tree diagram. An ice cream shop sells one-topping sundaes made of chocolate vanilla twist. You can get hot fudge, strawberry, caramel, or pineapple. And so you do that for each of them. How many different choices are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In example 2, suppose that the license plates may not repeat. So again, there is 6 digits. What I do is you can make a box, or sometimes I just make lines like blanks where I want to put the numbers 1, 2, 3, 4, 5, 6, and we're multiplying it together. Because it cannot repeat, that means in the first place there's 26 letters, in the second place there's 25. Please pause the video and try solving number 2. So the first letter is 26 choices. The second letter, because you can't repeat, so you've already used one letter, is 25. The third letter is 24. Now we go to the digits. We start off with 10, 0 through 9. But then once we use one of the digits, we don't repeat. So it goes to 9 and then 8. Multiply this together. You have 11,232,000. In example 4, you and 2 friends each spin the spinner shown at the right. What is the probability that each spin is the same shape? First of all, remember that we have favorable over total as probability. So let's list the favorable outcome. There are a total of 5 shapes. So I can, now remember all 3 spins need to be the same. So the first spin is a heart, heart, heart. That's one favorable outcome. Star, 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 that's the second. So this is one favorable outcome. This is 2. This whole thing is 3. Again, the shapes just have to be the same. So that's why there is 5 favorable outcomes. Now we can use the counting principle to find the possible outcomes. There is 5 choices for the first spin, 5 choices for the second spin, 5 choices for the third spin. So 125 total choices are possible. Again, the formula for probability is favorable over total possible. So take the 5 over 125, simplify to 1/25. There's a 1 in 25 chance that you're going to spin the same shape in all 3 spins.